Double lugging, the practice of connecting two conductors to a single terminal, is generally not permitted unless the breaker is specifically designed for it. However, there are exceptions. One situation where double lugging may be permitted, even if the breaker isn't designed for it, involves using a thicker lug or wire than the breaker's lugs are rated for, but not exceeding the wire gauge or overcurrent protection rating of the breaker. Another exception is using a load side auxiliary contact kit designed to fit the breaker's lugs. Thirdly, installing a surge protection device, or SPD, that is specifically designed for use with a non-double lugging breaker. Now, let's talk about passive parallel SPD. A passive parallel SPD can be installed on a non-double lugging breaker if it meets certain conditions. Firstly, the SPD must be installed on the load side of the breaker. Secondly, it must be designed for the voltage rating of the circuit. Thirdly, the SPD needs to have a current rating equal to or greater than the trip rating of the breaker. Fourthly, the SPD should be designed to be electrically isolated from the circuit, perhaps through a plastic enclosure or fiber optic cable. Always consult the breaker manufacturer's instructions and specifications. This step ensures that the proposed installation is permitted by the manufacturer and adheres to relevant safety standards. Double lugging or installing an SPD on a non-double lugging breaker without proper precautions can create significant safety hazards. These hazards include the risk of overheating, arcing, and even fire. It's always best to use breakers specifically designed for double lugging or SPD installation. These breakers have undergone testing and certification for such applications, providing an added layer of safety. Remember to check the breaker's labeling and specifications. These details will indicate whether the breaker is suitable for double lugging or SPD installations. If the breaker isn't rated for double lugging, using a listed lug that is rated for two conductors might be a valid option. In such cases, make sure the lug is properly torqued according to the manufacturer's instructions. Another alternative to consider is using a power distribution block. These blocks allow you to safely split a single conductor into multiple conductors, providing a safe and code-compliant solution for connecting multiple loads to a single breaker. Always follow the National Electrical Code, or NEC, and any local codes. These codes provide detailed requirements for electrical installations, including guidelines on conductor termination and overcurrent protection. Before working on any electrical equipment, ensure the power is turned off at the breaker. Use a reliable voltage tester to verify the circuit is energized before starting any work. A surge protection device, or SPD, is designed to protect electrical equipment from voltage spikes, which can damage or destroy sensitive electronics. SPD are typically installed in parallel with the equipment they are protecting and work by diverting excess voltage to ground. There are several types of SPD available, each designed for different applications and voltage levels. Some SPD are designed for whole house protection and are installed to the main electrical panel, while others are designed for individual appliances or pieces of equipment and are installed at the point of use. It's essential to choose an SPD that is appropriate for the specific application and voltage level to ensure effective protection. SPD are rated by their surge current capacity, which is the maximum amount of current they can safely divert to ground. A higher surge current capacity indicates a greater ability to protect against larger voltage spikes. The voltage rating of an SPD should also match the voltage of the electrical system it is protecting. For example, a 120 volts SPD should be used on a 120 volt circuit, and a 240 volts SPD should be used on a 240 volt circuit. When selecting an SPD, consider the type of equipment you are protecting, the voltage level of the electrical system, and the surge current capacity of the SPD. Also, look for SPD that are listed by a recognized testing laboratory, such as Underwriters Laboratories, or all, to ensure they meet safety and performance standards. Proper installation of an SPD is crucial for its effectiveness. Follow the manufacturer's instructions carefully when installing an SPD. Typically, SPD are installed on a dedicated circuit breaker and grounded to the electrical panel. Ensure all connections are tight and secured to prevent loose connections, which can cause overheating and electrical hazards. After installing an SPD, periodically inspect it to ensure it is functioning properly. Some SPD have indicator lights that show their status, while others require testing with a surge tester. Replace the SPD if it shows signs of damage or has reached the end of its service life. Proper grounding is essential for the safe and effective operation of an SPD. Ensure the SPD is properly grounded to the electrical panel and that the grounding conductor is of the correct size and type. A poor grounding connection can compromise the SPD ability to divert excess voltage to ground, increasing the risk of damage to electrical equipment. Regular maintenance of SPD is important to ensure they continue to provide effective protection. Check the SPD indicator lights or test it with a surge tester to verify it is functioning properly. Replace the SPD if it shows signs of damage or has reached the end of its service life. Also inspect the SPD connections to ensure they are tight and secure. Loose connections can cause overheating and electrical hazards. SPD can be installed in various locations depending on the type of protection desired. Whole house SPD are installed at the main electrical panel to protect all the electrical equipment in the house from voltage spikes. Point of use SPD are installed at individual appliances or pieces of equipment to provide more localized protection. Consider the specific needs of your electrical system when deciding where to install SPD. For example, if you have sensitive electronic equipment, such as computers or home entertainment systems, you may want to install point-of-use SPD to provide extra protection. When working with electrical equipment, always follow safe work practices. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Work in a well-lit area and avoid distractions. If you are not comfortable working with electrical equipment, hire a qualified electrician to perform the work. Always turn off the power at the breaker before working on any electrical equipment. Use a reliable voltage tester to verify the circuit is de-energized before starting any work. Tag out the breaker to prevent someone from accidentally turning it back on while you are working. Avoid working on electrical equipment in wet or damp conditions. Water is an excellent conductor of electricity, and working in wet conditions can increase the risk of electric shock. Do not overload electrical circuits. Overloading can cause the wires to overheat, which can lead to fires. Use the correct size and type of wire for the electrical circuit. Using undersized wire can cause the wires to overheat, while using the wrong type of wire can create a fire hazard. Inspect electrical cords and plugs regularly for damage. Replace any damaged cords or plugs immediately. Damaged cords and plugs can create a shock hazard or start a fire. Use ground fault circuit interrupters, or GFCIs, in wet locations, such as bathrooms, kitchens, and outdoor areas. GFCIs protect against electric shock by detecting ground faults and interrupting the circuit. When using extension cords, choose the correct gauge for the application and do not overload them. Use heavy-duty extension cords for power tools and appliances that draw a lot of current. Do not run extension cords under rugs or carpets, as this can trap heat and create a fire hazard. Avoid using damaged or frayed extension cords. Damaged extension cords can create a shock hazard or start a fire. Keep electrical equipment away from flammable materials. Flammable materials can easily ignite if they come into contact with overheated electrical equipment. Ensure there is adequate ventilation around electrical equipment to prevent overheating. Overheated electrical equipment can pose a fire hazard. In addition to surge protection devices, other devices can help protect electrical equipment from damage. These devices include voltage regulators, line conditioners, and uninterruptible power supplies, or UPSs. Voltage regulators maintain a constant voltage level, protecting equipment from voltage fluctuations. Line conditioners filter out noise and interference from the power line, improving the quality of the power supplied to the equipment. Uninterruptible power supplies provide backup power in the event of a power outage, allowing equipment to continue operating without interruption. When choosing devices to protect electrical equipment, consider the specific needs of the equipment and the characteristics of the electrical system. For example, if you have sensitive electronic equipment that is susceptible to voltage fluctuations, you may want to use a voltage regulator. If you live in an area with frequent power outages, you may want to use an uninterruptible power supply. Double lugging is addressed by the National Electrical Code, specifically Article 110.14. This section covers the electrical connections. Terminals for more than one conductor, or terminals used to splice conductors, shall be so identified. So, the terminals must be identified for that purpose, and if they are not, then you cannot put two conductors under one terminal. Equipment should be evaluated with the conductors landed properly, and should be identified, meaning labeled, as suitable for the purpose. Some manufacturers will label their breakers as suitable for accepting two conductors. You should always follow the manufacturer's instructions for the proper way to terminate conductors on their equipment. It's important to know that while some exceptions to double lugging exist, these exceptions do not supersede the importance of following manufacturer's instructions and adhering to all applicable electrical codes. Electrical work should always be performed by qualified professionals who are familiar with these codes and instructions. Failure to follow these guidelines can lead to serious safety hazards, including electrical shock, fire, and equipment damage. When in doubt, consult with a licensed electrician. The potential dangers associated with improper electrical work far outweigh any perceived cost savings from attempting to do it yourself or ignoring professional advice. Always prioritize safety and compliance when working with electricity.